Don't repeat yourself. This is actually an axiom that programmers repeat all the time, but it does bear repeating. The whole idea is that if you are writing code and you find yourself copying and pasting code from one place to another, you're probably doing it wrong. And it's worth taking the time to see if you can write that function one time. Just functionalize that little snippet of logic and use it multiple places. Write it once and use it many, many times. Now, in previous videos, I have said that CAD is code, and it literally is code. It's not kind of figuratively a little bit like code, it is code. You are just actually writing code using your feature list that produces your final geometry. But following the don't repeat yourself axiom in CAD is a little bit less straightforward than just writing a function and reusing it. Onshape is awesome, probably the best at doing this already, using features like the native derive feature. You can pull geometry from one place to another and do things with it. And if you update it in the source, you can update it all the places that it's used. It's awesome. But there is a custom feature that takes this to the whole next level, and that custom feature is called Amalgamate. This is not a feature that I wrote, actually. This one is by Derek Van Allen. But my whole thing at the Onsherpa is to help teams reach peak Onshape productivity. And it doesn't really matter very much to me whether that's using a feature that I wrote or a feature that somebody else came up with. So in this video, we're going to go over some examples and use cases for the Amalgamate feature with a special focus on creating solutions one time and using them many, many places all over your organization. Let's get to it. All of this, the entire battery door, the compartment, the labeling, everything was done in a single feature from the Amalgamate feature right here. If I roll before this, all of that goes away. So let me show you how I would go about adding that using this custom feature. So I'm going to choose Amalgamate. And here we get this drop down to go find geometry from other places. And I've already prepared this battery door. It's configured in all the ways that I need. So I'm going to set this nominal for my configured battery door to match the nominal I'm using, the nominal wall thickness I'm using for my plastic parts. And let's say that this one wants to be AAA batteries and I need 6 of them. I'm going to hit generate. And then once that finishes generating, I can click right here where it says battery door. And all right, nothing's happening yet because we need some locations and some scope stuff sorted out, but it's coming up quick. So I'm going to use an implicit make connector here on the bottom face. You could also, have created a make connector that you're defining in any way that you want to position this exactly where you want it to go. Subtraction scope is going to be this bottom part, and the union scope also will be the bottom part. And bam, we've got our nice battery door. Everything is drafted. If I pull up my draft analysis here, you can see that there is no yellow. Everything is at least 1 degree draft. Most places are 3. Shutoffs are even more than that. And likewise, the battery door itself is looking pretty good, nice and cleanly drafted. Looks like I need to reverse this area. I've got an undercut, but not too crazy to do. But yeah, you can see that this is an extremely powerful feature. And it's also, because the place where I'm pulling this geometry from is configured, I can update this very easily. If I wanted it to be for AA batteries, I can generate that instead. And we're done. So this is a massive boost to teams that recycle geometry. And this feature lets you essentially build out libraries, not just of parts or hardware or things like that, but you can actually build up libraries of reused geometry. A great example would be a snap fit that you got all the dimensions the hard way because you tooled that thing up and you did it steel safe and you shaved steel out to slowly dial it in until the feel of that snap was perfect. Now you want to codify all of that and you don't have to look it up again. Put it in a part like a geometry library, and everybody on the team can suddenly benefit from all of that. That's another huge benefit of this, is that all of the geometry here represents somebody's expertise on the team. And some of this modeling might be above the head of, say, your interns. No offense, interns. I was once an intern. But, you can have someone with some domain expertise producing the reused geometry, and then everybody on the team can suddenly benefit from that person's work and expertise. So that's a huge benefit. Let's go look at another example. Another way you might use this is if you're bringing imported geometry in and you need to cut out certain holes for that geometry. Once again, all of this was created with one Amalgamate feature, including these holes with correct callouts. So when I do a drawing of this part, you can see that we can still get the correct hole callout coming in from that. Let's look at one more example. Here I have a cabinet that has a couple of pieces of hardware we're going to be using, and I'm cutting holes just as I need for my Forstner bit and my pilot holes to put those hidden hinges in there. And I've also got a lock that goes here, and both of those are coming from an Amalgamate feature. And then over in the assembly, we can put the hardware itself rather than bringing that in. Looks like I have somewhat of a mating issue. Oh, that's because that's not even mated in space. That's on me. But yeah, so this feature is very powerful and lets you bundle up your work and reuse it all over the place. So really, really awesome stuff here. Let's walk through how I actually did some of these examples and how to use the feature. We'll go back to the battery door. So this feature behaves in a way that is very analogous to the sheet metal form tool. This is the native feature, and here lets you, I can pull from existing libraries of different sheet metal forms, and I have different inputs that I can change to make sure that I'm matching my design. But I can also create my own library if I want of sheet metal forms. And if you want to learn more about this feature and see how that's done, you can click this little question mark icon inside of the form feature, and it will take you to probably some videos and help documentation that you can learn about this tool. But if you're already familiar, then it will help to understand that the Amalgamate is very, very similar in the way that you set it up. So here I've generated a battery door, and I've modeled everything that I need to model to make this door, production ready. It's well configured. You can see I've still got a little bit of ketchup and mustard going on up here. And if I wanted to massage this even more, I think we could probably get that stuff ironed out. I'm going to leave it for now. But you can see we're configured. If I need to change the size of the batteries, rolling to the end, we're cutting the lettering away. And if I change the count on these, everything will rebuild. I didn't add any of the places for like the little contacts at the end. I have designed those in the past, but it was just, I'm just doing this model for a demo. So you guys can use your imagination on that one. But you could make this as detailed as you want it to be, and you can be as particular as you want to be, because none of that effort has to get redone on the next project and the next project and the next project, as long as this is some kind of standard geometry. Okay, so once you're here, we need to tag things to tell Onshape what to do with them when you bring them in. So in our example here, the battery door is a new part. It gets brought in by itself. This gets merged into the body that we're connecting it to. And crucially, we also have this removal body. This is what we're going to use to cut away from the part that we select in the subtraction scope. So I've got those three bodies ready to go. And inside, to use this, there's actually two features. There's one called Amalgam Tag, and that works very much like the form, like the tag feature here, where you can tag sheet metal forms. This is the native tool, but we have Amalgam Tag, and I'm going to use that. And then I can just choose the correct things for the correct spot. So for union operations is going to be the compartment. Things to subtract is going to be the removal body. Things to insert as new would be the battery door. And I can even name this battery door. And that will actually rename the Amalgamate feature later when I use it. So I'll just get rid of that one. And now that that is tagged, I can bring this in anywhere that I want and add as many of these as I want, even different configurations. Let's do this. Go here, not using the base clip, use that same battery door. I like to make sure the nominal matches whatever I'm really using. 2 AA's generate. Once that computes, then you click here. And that's what will kind of finish that process. Subtraction scope is this, union scope is the same. And now we've got a battery door where our screen should be. Excellent. But yeah, really powerful way to work here. Want to show one other little bit is that you can actually nest this stuff. And that's what I'm doing here for this. These are coming from their own place, and I'm using Amalgamate to bring them in and eventually cut them away from here. So you can kind of stack this stuff up. Like let's say, I don't know, you have to decide for yourself what units of geometry are going to be valuable to you. But let's say that you use this kind of finger cutout all the time for other stuff. Maybe that's actually an Amalgamate that gets added onto the battery compartment, and you might use it for other compartments as well, let's just say. Or this tab feature on the back, maybe that's something that you use. But any geometry that you find yourself using over and over again, you can do with Amalgamate. I do want to show you how I set up this part as well, because there's a little bit of trickery going on here to make the whole information come through. This is an imported panel mounted connector. And imagine at your company that you have a library of such hardware. You could go ahead and add to those parts all of the amalgam, like removal bodies for your geometry. And then you could even add, let's say, a very simplified volume that represents a space claim for this part. So you don't have to bring all this detail into your model to work with this part. You could bring in just a very blocky shape that covers the outside. I don't have that here, but you could certainly do that and bring that in as a new body to work from rather than bringing all of this into your part studio, which is typically ill-advised. But all right, let me show you how I was able to get the threads on here to transfer and keep the whole information. The trick here is you can actually do it in reverse. I modeled this little dummy plate and I punched the holes in that. So I'm modeling exactly into this plate the stuff that I want cut away. And then I make another plate that overlaps that completely. You could also have duplicated that up here using the transform tool set to copy in place. It doesn't really matter, but in the end, I'm now subtracting the one that does have the holes in it from the one that's just a solid block. And it leaves me with this geometry, which incidentally keeps the attributes required to call these out in a drawing, even though these are now positive shapes instead of negative shapes. And once we tag that, bring this into the other studio, and basically we're Boolean subtracting this away from something else, the whole information stays with it. So pretty neat trick. So these are just some examples, and I know that there is so much more that you can do with this feature. Let me know in the comments what comes to mind for you. I'm sure that the work you do has some specialty applications where this would be perfect. And I want to reiterate here that there's not many opportunities in CAD to do things whose impact scales. Usually, most of the work you do is on one project solving one problem, and then that work is done. You ship it and it's done, and you have to do more work to get more done. But with things like this, when you're setting you and your entire team up for more success, the value of this continues to grow. It keeps giving after every single use that people put into it. So whenever I see an opportunity to do CAD work that really scales in value, I am always going to take that if I have the time. So I highly encourage setting up, if you have a hardware library that has unique geometry like this, you can set up to where all of your hole cutouts are right there, and you can have keepouts. And if you have reused geometry, like that battery door example, I strongly recommend setting up libraries for that to share with your whole team as well. Thanks for watching.